So I will connect, and in this case, again, I will run the import of libraries. I think that we will use only part of them. Here are many which are not used anymore, but it's fine. Yeah, an advantage is if you have a GitHub account. Do you have a GitHub account? So in that case, I'm not sure if you will be able to run all the code, but you can try it, or you can develop, you can run it later on once you will have a GitHub account. I realized that this today morning, and it even seems that a GitHub account itself is not a solution. GitHub account and a password, that you need some tokens from GitHub and to run the script. Because what we do here, we send a huge number of requests to GitHub straight from Python, and GitHub does not like it so much. GitHub likes much more once you just download a whole folder, a whole repository or something like that. What is reasonable. But this is also quite handful, so I will go through it. So imagine this situation. First, you have to log into GitHub here in Python. I have here produced this command for doing this. So I am on GitHub as under this name, and it will ask you iteratively also for a password. So, and it's hidden, so it's fine. So, and now I authorized a session access in GitHub, and I have this session in this variable called G, and I will use this variable with containing my credentials for asking GitHub for some data. I have to let to know GitHub in what user and what repository I am interested in. And in this case, for this example, I am interested in this user. Perzos digital library is on GitHub as a user, or as an organization, but user and organization behaves similarly. And it has now 45 repositories. And among these repositories, there is whole Greek literature, which is available on Perseus, and also the whole canonical Latin literature, which is available there. It is in GitHub, it is located in the folder called data. And here is it in a nested structure in all these folders. For instance, we can open one folder, and within this folder, there are different documents, and in these documents, there are these files. So you have to go through all this. Once you want to get to an individual XML file with a XML file with a document located on Perseus, you have to go through this tree, through this structure, to the final file, like here. I don't know what file it is, but you can see the XML file itself. That's the similar structure we have seen. Yeah, it has this stay header, file desk, something what we have already seen in the corpus corporum, according to the TEI standards. And here we see the document itself. And the great thing is Yeah, here is the raw version of it with this stable URL address, and here we can see the exact location, the relative path, the absolute path within the repository. Yeah, master. So the question is, once we know that there is such a repo on GitHub containing a lot of interesting XML files within a file folder structure, how we can retrieve all XML files here in a straightforward way, perhaps even without doing something what is very common, that you will just clone or download the data from here to your local machine. I suggest that this is unnecessary step, and that you can proceed without that step. You can just run the right commands in direct, straightforward in your Python environment. And it's actually the task of this script. So what I am doing here, or what this script is doing. First, it calls the repo and locates the repository into a variable called repo. It then produces an empty list, which we will iteratively fill in by data we are interested in. The data we are interested in are actually the paths for individual files, all interesting files in the repository. So how to obtain this? Here we go navigate through the repo to the folder called data, and then we use this loop which goes through all directory. It goes through all directories here, and for each tries, okay, I opened this. Is here any XML file of I am interested in? No. So goes deeper. Is here? Yes, it is. Does it contain Latin Perseus lat in its title? Yes. So let's copy paste. Let's extract this file name and put it on the list. And in that way, it go. Harris is the Harris, Zelig Harris, exactly. In that way, you can iterate over through all this repository. All you need is just this sort of command, and I can run it. And it's actually fills in this file paths list by all file paths which are within the repository. So at this moment, we do not scrape the XML files themselves. We just scrape their paths in the repository, within the repository. So it takes some time, and but I was here already before, and here is the output for the whole repository. We can inspect how many files we have here once we will be ready. So here you can see the whole path through the repository. Yes. So this repository has almost 400 XML files containing Latin literature, which are coded here using this Perseus let2 attribute, or let1. Sorry, I use both. And I now have the path for all of them within a list. Here is again what we already seen and what we were testing with. Here I use one of these paths here, the first one, and put it into this variable path example. I can split it here. So I have now this string as in this path example variable. And now I simply put this variable here behind this general URL for the whole repository for getting the raw data in the repository, and do exactly what we did in the case of Corpus Corporum website. That means that I make a HTTP request, obtain a response, and I interpret the response into a tree structure of an XML file by using beautiful soup. So again, we have this, and I can again print the metadata here, just for curiosity. Once we want to get the text, that was sorry, not this way, I think. So here I have the document itself. So far, it's the raw document, no cleaning, just the text. So that's for individual file, but we are interested how we can use all these paths here in this variable file path to extract all the files from the repo. And here is a function for that. With the just for testing, I have here this random choice function. What I have here do here is just for testing that I use. I take this file path, which is the variable containing all these paths, right? Almost 400 of them. And from this, I generate random choices. It's just for testing that I generate any 10 file paths from this variable, right? Because because otherwise I would easily get some error, and I want to avoid that. But yeah, we can see that to use this method to obtain or to retrieve any 10 XML files within this list, I need just 5 seconds. Or 3 seconds right now. I can make it even more simple and just put here, take here first 20 elements on this list. Here is the list of paths, and I put here first 20. And now I want to get all these files here, all this 1, 2nd, 3rd, 4th, 5th. Yeah. So and I make it in this way, within a loop for file path, and on this list made response, because here is the I put here from here and put it here, generate a soup from the response and extract the string from it, extract the author of the text, and the title, or all variants of the title of the work, except avoid any errors by running try and except, and append it into a new variable list called data. How much time it will take? I extract 20 XML files. So in 7 seconds, I have 20 files. And I have it in the data variable, and the data variable has currently this shape. Here is the author of the text. Here is here is the name of the file, the author. Here are all variants of the title, and here is the text itself. You can expect just one output. For instance, when I run 7, one, 2, 3, 4, 5, 6, 7. Now I have this, looking at this file. This should be one, this one. So it's from Timasius Plautus. It's all tags called title, and it is the text itself is here. Having this form, I can easily produce a data frame and have 20 XML files in a tabular format. Here is the file name. Here is the title of the work, all variants. Is also this machine readable text. And here is the string variable. It's much longer than here. Here we see just part of it. So this is why the random was interested in, because we could obtain works of many different authors. File paths. Correct. No. Random choices, is it? I don't remember. Yeah. So now we have the same. And again, we can produce a data frame. So now we have much more individual authors because we used random files on the list. And we have the text here. So it's now much larger amount of data. Here again, some very minimalist cleaning. And here I just extract this document here and produce a list of words from it. This is data Perseus, the data frame. I am interested in the column string. In this, make a list from it, from this. So I have a list of these strings now, and I call the first one by using 0 for the first element on the list, and I apply a split function on it, or split method on it, dividing it into individual words, and at the same time doing some regular expression cleaning, removing new line characters, and here is the output. So I could easily do this in a loop and to make it for all the documents here. So the question is how much time it will take once I will run it on the whole dataset, on the whole list of almost 400 XML files. My guess is that it will be about 3 minutes or something like that. So at this moment, your machine is in a completely relaxed mode because everything is just happening just between the GitHub server, which is sending the data to the Google server, managing your Google Laboratory. And so I think that it's even more straightforward than downloading the data from GitHub, doing something on them, importing them, uploading them to some environment, and so on and so on. You just have to trust that GitHub will be here